In this section, we're going to look at the derivatives of trigonometric functions. We've done a little bit with intuition, but in this section, we're going to look at them graphically. We'll probably look at them graphically first, and then we'll move into an algebraic proof, and then we'll memorize the formulas that go along with it. Please ask me in class for the derivative formula sheet, so I'll give you a list of all the derivatives and as a formula worksheet that you may find helpful. Okay, so we're going to start off with what is the derivative of the sine of x? Okay, so we're going to go ahead and we're going to graph the sine of x, and when we go ahead and we graph that, there's our graph. So in blue, you're going to see the derivative of the sine. Okay, now in order to get the calculator to graph the derivative, we're going to go y equals, and I'm going to go down to y2, and I'm going to hit the math key, and I'm going to go down to number 8. And you'll see this calculator has the different updated software programs. So we're going to take the derivative with respect to x of, you're just going to type in, we want to take the derivative of the sine of x, okay? And then we're going to go over here and we're just going to say, you can plug in the point, we're just going to add x equals x. Okay, and now we're going to graph that, and you're going to see in blue the sine, and you're going to see the derivative is the other graph. What does that graph look like to you? So before I say it, stop and watch the graph and see if you can take a guess as to what that graph is. To me, it appears that the graph of the derivative of the sine ends up being the cosine of x. Okay? So now we're going to prove this to be true. All right, so in order to prove this, we're going to use our definition. So I'm going to look at the limit as h approaches 0. Okay, our function is f of x equals sine of x. So I'm going to do the sine of x plus h minus the sine of x all over h. Okay, now we have a trig identity. This is a little review from pre-calc, but we have a trig identity that tells us that the sine of x is equal to, sine of x plus h is equal to the sine of x cosine of h plus cosine of x sine of h. Okay, so then we're going to say the limit as h approaches 0, sine of x plus h is going to be, I'm going to substitute this in. I'm going to say it's going to be the sine of x times the cosine of h plus the cosine of h minus, cosine of h times the sine of h minus the sine of x over h. Okay, so then I'm going to say the limit as h approaches 0, and we're going to then take out the sine of x. I'm going to take this term here and this term here, and I'm going to take out a sine of x. So if I take out a sine of x, I'm going to be left with cosine of h minus 1. And then I'm still going to leave this plus cosine h sine of h over h. Okay? All right, now I'm going to break it up. Remember, my goal is to show that this is all equal to the cosine of x. So the limit as h approaches 0. So now I'm going to split up this fraction a little bit. I'm going to split this up as the sine of x times the cosine of h minus 1 over h. Now I'm being kind of selective and putting this into pieces that will work, plus the limit as h approaches 0, and in this case I'm going to put cosine of, this should have been a cosine of x right here, and this should have been a cosine of x. So I'm going to put the cosine of x times the sine of h over h. Okay? And now I can split this into even more pieces. So this is the limit as h approaches 0 of the sine of x times the limit as h approaches 0 of cosine of h minus 1 over h plus the limit as h approaches 0 of the cosine of x times the limit as h approaches 0 of the sine of h over h. Okay, so this is basically 4 different pieces that I can just take these limits using substitution or doing them graphically. All right, h you substitute in, you're just going to get sine of x. If you graph its limit, the height that it intends to reach at when h approaches 0 is 0. Okay? If you do this and you graph, sorry, you can't graph this, so you can't substitute h in, so it's just going to be cosine of x. And this, if you graph it, you're going to get 1. So sine of 0 is 0, so you're just left with cosine of x. Okay? So I've just proven that the derivative of the sine of x is equal to the cosine. Okay. And that matches with our graph that we had. The derivative of the sine was the cosine. Proven. All right, here's where your part comes in. Now, what I would like you to do is use this exact same strategy that we just did. I want you to tell me what the derivative of the cosine is equal to, and I will give you a hint. It is not just the sine. Okay? So I need you to tell me what the derivative of the cosine is. I need you to present a proof take a picture of your work where you show the proof, and also come to class with a graph showing what the derivative of the cosine is. So you have two things to do. One, graph on your calculator and determine what the derivative would be. And then second is generate a proof of what the derivative of cosine is equal to. Okay? Looking forward to seeing your proofs.